know the sun has three layers, and the innermost layer is just about 5000 degrees Celsius hot, while the outer one is over 1,000,000 degrees hotter. Do you know that the sun ejects these powerful magnetic material which go in different directions and can even damage the satellites in space and reach the Earth? Well, solar physicists across the world have struggled to find answers to these questions for years, but have not been able to. Several missions in the past, led by NASA and European agency, have also tried to unravel these mysteries. Now there's another addition to the list: Aditya-L1, India's first ever scientific mission to study the sun. So when the rocket lifts off from Sriharikota on September 2nd morning, it's going to place a spacecraft at a point called L1 between the sun and the Earth. Now the distance of the sun from the Earth is about 150 million kilometers, and no spacecraft can touch the sun or it's going to burn it. So what ISRO is planning to do is that it'll place the spacecraft at a point called L1, which is 1.5 million kilometers from the Earth. So we still will be very far from the sun, but it'll give the scientists a vantage point to monitor the sun for 24 hours for the next 5 years. Now, the amount of the data and observations which will be collected will help scientists unravel the various mysteries of the solar system. But why have we planned this mission? So Indian scientists have been studying the sun for a very long time. We have data and observations dating back to almost 100 years ago. But all these observations have been taken from the ground stations. But that's where the problem comes in. So when scientists are trying to study the solar radiations, these solar radiations reaching the Earth tend to get scattered when they hit the Earth's atmosphere, and the images that the scientists get are usually blurred. Second, they are restricted by the sunrise and the sunset timings. Also, importantly, when they're trying to study the corona, which is the outermost layer of the sun, they can't do it until there's a total solar eclipse, and that is a rare phenomenon. So that is why they want to send a spacecraft into the space so it can get an unhindered view of the sun without any eclipse for the next 5 years. So Aditya-L1 carries about 7 payloads, which have been built by several scientists from different institutes across the country. Out of them, the most important payload is VELC, which is Visible Emission Line Coronagraph, built by scientists from the Indian Institute of Astrophysics, Bengaluru. Yes, that's right, that's one of the oldest scientific institutes in the country. Now, this payload took almost 15 years of hard work led by these scientists to integrate critical components into one payload. It's about 190 kgs, and it's going to study the coronal mass ejections. So what are these coronal mass ejections, or the solar flares that these scientists talk about? So the sun has a lot of reactions which keep happening on its surface. Sometimes this billion tons of magnetic material can get ejected into various directions in the space, and this can even damage the electronic equipments on the satellites. Now we know that our life depends a lot on these satellites for communications, for navigation, for GPS services, and for monitoring the weather across the Earth. Now these powerful magnetic storms can damage these satellites, and we really need to predict when and where these solar flares or these coronal mass ejections can happen. So that is why these scientists have been planning solar missions to understand these phenomena and help them predict in the years to come.